All right, ladies and gentlemen, this is information on relative humidity and dew point for Unit 2 of Meteorology. These are a couple of tricky concepts, but they play off each other, so stick with us, and it should make sense, hopefully, a little bit more by the end of this PowerPoint presentation. So the hydrologic cycle or the water cycle, you probably heard about this in elementary school, right? It's this idea that water in all of its forms, solid, liquid, and gas, circulates through our atmosphere in a lot of different ways, but it cycles, right? It continues to fall, evaporate or vaporize or transpire and work its way back up into the atmosphere, formation of clouds, precipitation, blah, 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 yada, yada, yada. It just goes around and around, right? So we're going to take a look at a couple of very specific aspects of the hydrologic cycle. So when we talk about water vapor in the air, first of all, understand we're talking about a gas. I'm not talking about something that's visible that you can see. Clouds are not made out of a gas. They're made out of actual water droplets, right? So but when we say water vapor, we mean it's a gas and it's always there and it messes with our hair. Makes it absolutely difficult on an incredibly humid day to keep our hair the way we want to keep it, okay? This is humidity, but there are three different ways to measure humidity. I'm going to show you all three right now. Two of them probably won't make a whole lot of sense to you because we just don't see them in the US very often. The first one is absolute humidity. To find absolute humidity, we take a look at the mass of water vapor in the air compared to a volume of air, right? How much water vapor is in a given space. And so this gets described as grams of water vapor per cubic meter of air, right? So if you take a meter stick by a meter stick by a meter stick and get this cube, how many grams of water vapor are actually located in that area? This does not get reported very often, if at all, in the news in the United States. The second kind is specific humidity. You can report this by the mass of water vapor in the air compared to the actual mass of the air instead of the volume of the air. So this gets reported as grams of water vapor per grams of air. And it also not reported very often, if at all, in the news in the US. But the third kind is. The third one is relative humidity. This is the amount of water vapor that we have in the air compared to the amount that we would need for that air to become saturated. And by saturated, I just mean 100% full of water vapor, okay? This gets reported as a percentage, and this is the one that we use in the United States, which is interesting because it's also the most difficult to understand. Why would we have gone with this one? I don't know, total speculation, because we like percentages. People like to hear, instead of grams per cubic meter, they want to hear 72%, right? But the issue is 72% for relative humidity. It's relative. That's why they call it relative humidity. What that actually feels like and how much water vapor is in the air totally depends on the temperature, right? It's all relative. So it's tricky. Look at this chart, all right? I know this is not the most exciting chart in the world, but here's the point I'm trying to make. The green line on this chart shows how much water vapor is in the air at 50% relative humidity, okay? Along the bottom, we have temperature in Celsius, and then along the side, this is how much water is actually in the air. This is our water vapor. So notice that as the temperature increases, as it gets warmer, 50% relative humidity along this line increases to show there's more and more and more water vapor in the air to keep that 50% relative humidity reading because the temperature is going up. You'll see why in just a little bit, okay? The red line is 100% relative humidity. This is where dew starts to form on things. You can't have any more water vapor in the air technically. It's at 100% total saturation. So look at these lower temperatures. When it's 10 degrees Celsius outside, the difference between the green line at 50 and the red line at 100 is not particularly large. There's not a real big difference in those cold temperatures between 50% and 100%. But as the temperature warms up, as it gets to be 40 degrees Celsius, look at where 50% relative humidity is versus 100% relative humidity. That's a pretty significant gap. That means you've got to have a lot more moisture in the air if the temperature is warmer to hit 100% versus 50%. So what do those percentages for relative humidity actually mean? It totally depends on the temperature, right? But we like percentages in the US, so we went ahead and started reporting that one. This leads us to the heat index. If you are outside and there is also a decent amount of relative humidity in the air, something funny happens for people that are alive, okay? Pets that are living. you experience a heat that is not the actual temperature, but it is just how hot it feels to you. And this is the heat index. The reason you have to be careful with this, even though it's not the real temperature outside, your body will respond as if the heat index is the actual temperature, right? Let me give you an example. If it's 92 degrees outside and we have 70% relative humidity, if I follow 92 down on this chart to find where 70% relative humidity matches up with it, we come up with a number of 112. It is not really 112 degrees outside. A thermometer, unless it's a fancy one that shows you heat index, will not show 112 degrees outside, but your body will respond as if it is actually 112 degrees outside. And this is because the temperature added to the fact that there's humidity makes it feel hotter, right? Now, why? That's the million-dollar question for the day. I'll give you a little hint. Our body, in an attempt to cool itself down, will sweat. But sweating does not actually cool your body down. What the sweat does, when it's sitting on the surface of your skin, does actually pull heat from your body. And if there's a lot of humidity, if there's a lot of water vapor in the air, it becomes very difficult for that sweat to go anywhere. It just sits on your skin. And so your body cannot cool itself down efficiently. We will talk more about that on another day. It is worth mentioning, this is not particularly clear, sorry. There's an opposite to heat index, and that is wind chill. That's the actual air temperature outside and how quickly the wind is moving by. That creates temperatures that are colder than it actually feels. All right, it's not the actual temperature, but it is how cold it feels. So for example, if we are at 15 degrees Fahrenheit on this chart and the wind is blowing 60 miles an hour, if we follow this chart down, that means that it will feel like negative 11 outside. It's not really negative 11, but your body feels like it is and will respond as if it is. All right, so this leads us to this idea of dew point. Stay with me here. If the temperature outside cools off, eventually the air will become cold enough that dew will start to form, okay? And when dew forms, whatever temperature it is outside, that means that the air is at 100% relative humidity. It's totally saturated. And that's why all of a sudden moisture just starts to condense and show up on things like grass and cars and people, right? And that's what we call the dew point temperature. The tricky thing is the dew point temperature is not the same every day. It doesn't happen at exactly the same temperature. Sometimes it's above freezing, right? And we get dew that forms, condensation that forms, and sometimes the dew point temperature is below freezing and we get frost that starts to form. So I have a video posted for you that we'll watch later today with a couple of beakers that will show this idea of when the dew point actually forms. All right, so drum roll, which temperature is dew actually going to start to form? It totally depends. We will do a lab demo where I show you dew actually forming on the outside of a can, and we'll figure out what temperature it is. But if we do that same demo on another day, we might get a completely different temperature. It just depends on how much water is actually in the air. Okay, I'm going to have a link posted in the daily deal for you to watch us with the beakers and water to show you relative humidity and dew point, and then later in the class we will actually do that with a tin can. Have a great day.